All right, so folks, today's agenda is about Azure Durable Function. So we have this fantastic serverless framework called Azure Durable Function, and we know serverless is where we are headed in this cloud native computing world. Okay, so just a quick minute to talk about myself. My name is Victor Chin. I've been doing this business for about 20 plus years. I've worked my way through system engineering, development, database engineering, Azure cloud, and there is a link to youracclaims.com/user/Victor Chin. Yeah, that's that. If you come across anyone that has more badges than I do, please drop me an email. I'm gonna see how far behind I am. Okay, and I'm gonna one up them. So there's that. So I've been doing this for the last 20 some odd years. My favorite thing to do. All right, so let's start by discussing what Azure Durable Function really is compared to the normal Azure function. So I'm going to draw some quick contrast. Now today we have 45 minutes, so I'm going to focus a lot on the code. I'm going to give the first 10 minutes to give an overview of what I'm trying to show you. Okay, and then I'll take the last 25, 30 minutes, walk you through the code because code don't lie. Code is truth. All right. So a couple of things we want to talk about is defining what is the purpose of Azure function. The Azure function is code-based glues. Okay, so I consider this a technology that serves as glues. As our enterprise develop more and more HTTP services, REST services, we need a way to connect these through codes. Okay, we also have ways to connect them through graphical workflow. Those are logic apps. So the standard Azure function defines triggers, and triggers define its dependency. Okay, so this is the first piece of the glue. So let's say we want our Azure function to monitor a storage account, to monitor a queue message, to monitor a service bus, to monitor an HTTP request. Our Azure function will run in response to those trigger conditions. Okay, now you may have you should be aware that your Azure function is completely stateless. So that means between invocation, let's say I have an HTTP triggered Azure function, and let's say I trigger this 5 times. Now, for all intents and purposes, they could all be on 5 different machines in Azure. So it's completely stateless, and throughout the execution itself does not store any persistent data. Now, any data that requires persistence needs to come externally. So in other words, we need to use Cosmos DB, we need to use Azure SQL, we need to use Azure Storage in order to look up state. Now, when you run the normal Azure function, you have 10 minutes that you pay because Azure function is pay by these gigabyte per second pricing model. So that means every second that your function execute, you pay an X amount of money. Okay, so the execution time is limited to 10 minutes, and by default, it only runs to 5. And then your Azure function gets killed. Okay, so you can, of course, change that on the host.json to change the limit up to 10 minutes. Now you pay for every second it runs. So that leads us to the next question. If our Azure function is calling something external, so let's say we consume a service in our Azure function, and that service happens to take some time. Now we run into this double billing problem. Let's imagine we use Azure's cognitive service, voice recognition. Okay, we can do that. And let's say you have a 5 minutes audio clip, and then you send it for voice recognition. You realize it takes 5 minutes to get it interpreted. So you're paying for the voice recognition service, and you're paying for the you're also paying for that Azure function at the same time. So you're paying two things at once. So that's some of the things with Azure function. Now for stateless workload, it serves just fine. So to run long-running process, we gotta have a different set of framework. What if our code needs to be stateful? Okay, so we need to rethink about if we have, let's say, now if you picture, we have a farm of machines. We have a farm of machines. And I'm talking thousands of these machines that makes up the function hosts. The power of the function is that it can run on any of these machines. So that we can pretty much linearly scale out our capability. But the challenge here is we still need to be able to maintain stateful workload. So what we need to achieve this is to be able to have a single workload. Let's say it started on this machine. Have the Azure Function Framework handle the persistence. So if there is a moment where this code is going to enter idle, such as the moment that it needs to call out to the cognitive service and it's going to wait for 5 minutes, we want this function's environment, these function hosts, to be smart enough to dehydrate this workload instance or this function instance. So when a 5 minute passes, any other machine can reconstruct the state. Now notice I'm using the word reconstruct. It's a very important concept. It's not serialization, deserialization, it's reconstruction. Okay. This reconstruction essentially replaces deterministic method calls to quickly fast forward the instance of workload to the moment it went into hydration mode. So in other words, it plays forward very quickly because all those prior calls has already been completed and its history being recorded. So when we reconstitute or reconstruct that workload instance on another host, that instance can be brought up to the state the moment the last time that function host went into hibernation. So it is the framework that needs to provide these transparent state management using Azure Storage. Now, folks, I have not used the word serialization and deserialization. My intention is to ensure you don't think like that. For the first few weeks I'm studying the Azure function, I always assume that these instances are somehow serialized and deserialized across the storage, but it isn't. It's simply a replay of all the events. Okay, so the concept of suspend and replay across any number of hosts is vital. So Microsoft can build out this huge fabric of machines, and your stateful workload can run, suspend, resume on any of the hosts without losing state. Okay. Now, to understand durable function, we also need to make sure I explain what this 202 response means. Now, remember, HTTP is a request and response. So that means that a request is not done until a response is received. Oftentimes, these requests may not be fulfilled within reasonable amount of time. So the correct approach for anything that's long running is the server immediately returns a 202 to acknowledge that the request has been received. Along with the 202 is a response header that says retry after. That tells you you should come back in 10 minutes or so, and here's the location you come back to. So these are all in the form of the 202 response. So the location tells you where you can check the status, and yes, we did receive your request. Okay, so this is what we call the 202 response and check pattern. Okay, now Azure Durable Function make use of this greatly in communicating to the client, hey, we got your request and it's going to take time for me to finish what you wanted to do. And here's a URL you can check for its status. All right, so I will show you that these allows you to implement certain application patterns quickly. Okay, oops, I'm not editing PowerPoint, am I? Okay. We'll take this one step further to show you what an entity function. So imagine you have a database without a database. You have a bunch of customers, you have a bunch of bank accounts, you have a bunch of transactions, and you won't need a relational database to store them. They will all be objects living in this fabric at all times. All right, and you can also create eternal orchestration that has infinite loop, but you're not paying all the time. Okay, so you're only paying when certain event occurs. All right, so quickly, when you start a durable function, you need something. So you need a orchestration client to be supplied with a bootstrap client function. Our bootstrap client function will be an HTTP trigger, and it will supply an orchestration client. And the orchestration client will start the durable function that's long running. Okay. All right. And these orchestration functions will then go out and call the various activity functions. And at some point, these activity functions will encounter a moment where it has nothing to do. Okay, so for example, this activity may send an SMS until the person come back and tell us what code he received. There's nothing for our function to do. So anytime we see this await keyword, it's a moment for us to say, hey, instance, persist yourself. Wait until something occurs, then rehydrate yourself somewhere else. Okay, so understand that this await is the moment where the orchestration client says, okay, I got something I have to wait. So my orchestration is completed so far until what I'm waiting for actually happens. From that moment on, you are not paying. Microsoft is paying for that infrastructure in order to wake you up and resume your workload. Okay. So upon the await completion, the orchestration restore suspended state by event sourcing all executed functions. All right, it doesn't sound like English, but event sourcing is a concept that later on I'm going to show you. A bank account. A bank account never have current balance. The bank account consider current balance by replaying all the transactions from beginning of time. Okay, so we call that event sourcing. The current state came from a series of events that cause the state change. So event sourcing is a concept that's applied to Azure Durable Function in order for the function to persist on one host and rehydrate on another. All right, so time to play with these codes, hopefully. All right, some of the common use case I will show you is function chaining. So during this function chaining, I can have one orchestration function call multiple activity functions. All right. So here's the basic activity function. Okay, so right now I'm going to show you the quick bootstrap. Okay. So I have a very generic HTTP bootstrap function, which let me demonstrate different activities that I want to show. Okay. The first one I will run is called a timer sample. This one shows you that you can chain activities. Now, this is going to start the timer sample. This is the bootstrap function. So our HTTP is triggered here. We are injected a durable client because we request for it. This will start the activity that's requested. The first one I will demonstrate is called timer sample. Now notice the starter must return immediately. This is the moment that 202 is generated. And that 202 will return a check status URI for you to check what's going on. And it will include a location for you to find the current status. Okay, so just like a normal function, I'm going to run it. I'm going to run it locally. I've also prepared a Visual Studio Code used to submit the request to begin the durable function. All right. Oops, let's not change that. Okay. Oops. Okay, this one's not running anymore. Good. Okay. So my durable function is ready for me to try the timer. Okay. So here's my timer activity. And I want to quickly give you some idea of what's going to happen when I trigger it. So in this timer function, I am chaining a few activities. So in this timer sample, if I ask a C# developer, you need to sleep your thread for 30 seconds, they will call system.io.threading, system.threading.thread.sleep or something to that effect. Okay. Now that's how we would do it without Azure Function. In Azure Function, I'll be calling one activity that returns a string. That activity is called timer sample hello and passing the string of Tokyo. Now this activity is really quick because it just receives and returns at the end of it. So it's really fast. After the Tokyo is called, I'm going to add a delay timer. Now this delay timer came from context. That's really important because I need a context to do the timing for me, not myself, because my code is going to get frozen. My code, my execution will be dehydrated the moment I call await timer. So it's not my code that's waiting for the timer. It's the context. It's my durable orchestration context. That is the guy that Microsoft's paying for the next 30 seconds and ensures that I am rehydrated somewhere and replay those state to get me back to this point so I can invoke the other two activity. So understand that that 30 seconds timer will not cost me anything. Now I can add a timer up to 7 days. At 7 days, I must wake up and I might want to register another timer and sleep for 7 days. So this is how you could create an eternal orchestration. Wake up every 7 days, look around, if nothing to do, go back to sleep. All right, so once all three action is done, I'm going to return the output as an array of strings. Now, these are normal Azure functions. There's nothing special about it except these are considered one of the activities. Okay, so this is the actual source code. All right, so it's running and it's waiting for me to give it a try, and I'm going to do just that, timer samples. Cool. Okay. Send requests. It's waiting. Okay. All right, so what's going to happen, like I described, I think I did more than once. Okay. Now, the idea here is the server creates a response message right away. And within that response message, it tells us, okay, we have something that's long running, so I got you. I got your request. Here's the location where you should come back to after 10 minutes, or after 10 seconds. 10 seconds, I think. Okay, retry after, and the location. So this is going to give you a status query get URI and a few other URIs. We will see the other ones in a moment. I mean, terminate post URL. You post to that URL, you terminate this instance. Get rid of all the histories, self-explanatory. If your function is waiting for an event to occur, you can send the event that way. All right, so I'm going to click on this. And depends on whether 30 seconds has gone by. Apparently it hasn't yet, so it's still running. So at some point, it's completed. All right. Okay. All right, so this is the 30-second timer started at, and then this is when the timer resumes. And that's when everything finishes. That's my first example. Okay, this one we'll call 3 activities where there's a timer, not just any regular old timer, but a durable timer. When you await for it, it suspends the state. So before I go further, I'm going to show you the Cloud Explorer. Now in this Cloud Explorer, this storage account is what's responsible for keeping the state of the invocation. All right. So this is the timer function. All right. And this is what the state looks like. All right. Now, folks, it's really important that you are aware where they are, but please make sure you don't depend on it. Okay, the point is not depending on it. Okay, because Microsoft can change the implementation, can change the way it manages the storage persistently. We need to be ignorant of it. Okay, so while we can see this and all these activities is journaled, for your own curiosity, you can look at the histories about when an orchestration starts, when it resumes. But please keep in mind that the purpose here is to be persistence ignorant. Okay, so the idea is that we don't touch or manipulate this, but this certainly can give you an idea. Okay, when orchestration, whenever you see this, okay, whenever you see this, we're dehydrating the instance. Okay, and orchestration started means it resumes. Now every one of them, they share the same execution ID. It's for the same invocation. All right, so this is when it finally completes the execution. All right, this is when task is scheduled. Task completed. All right, anytime you see that, that means it's awaiting for something. Okay. All right. Now I want to show you the durable function is capable of fan out. So this is the second demo, beside chaining a series of activities, this fans out. So that means in parallel, I'm going to have my function do all four of this. Now, what is interesting that I'm trying to demonstrate is that while the first three are synchronous calls, so that means when this HTTP GET happens, okay, when this call HTTP async, this takes advantage of the HTTP API from Durable Function. So Durable Function also give you an HTTP API to make HTTP calls. It's smart enough to handle the 202 for you. The first three is just downloading web pages, no big deal. The fourth one is calling our own timer sample. And if you recall, our timer sample returns a 202, and it must be checked regularly to find out if it's done. The HTTP API from Durable Function includes that 202 handling for you automatically. Okay, so this demonstration will show you fan out, while three are synchronous calls and one is asynchronous calls. And this one is called a fan out example. So let me start this back up again, and I'm going to try the fan out. Okay, and notice my code creates four lists. Sorry, a list of 4 items. Okay. And I'm using a task.when all means when all the tasks completes, then proceed. That means I'm ready to look at each response and pull the status code, how many bytes are there together, and show you 500 characters of those response. Okay. And what's interesting to note is that once I start this await will automatically handle the 202 awaits here. And only when that is done, this for each will proceed. Okay. All right. So getting the function towards our get going. Yep. All right. So it looks like I'm ready. Okay. So my job host is ready to rock. And this is the fan out request. Here we go. All right. So you see the fan out request took place. All right. Bunch of things happening. Okay. So right now I'm sure the google.com, msn.com, and whatever.com is already finished. Because afterwards, just a web page. So right now, it's still continue to run because I still have one last one. So the Google, Amazon is already done. But since I'm waiting for all of them to finish, because I don't want to proceed until it's all done, now this call HTTP async is handling the 202 and retry. So at some point when 30 seconds is done, when the timer sample is done, okay, when the timer sample is done, all the tasks are completed, and then all the output becomes available at once. Okay, great. All right, so some of them has less than 500 characters. Okay, no worries. So let me just take a few less characters. Now this is the chaining and the fan out. The third type is called human interaction. So I'm going to run this one more time. This is my fan out. Let me close this. And I'm going to keep an eye on this. So if it shows up red stuff, then I'm going to be a little bit worried about. Then I'll check what's going on. All right, I'll let it do its thing. The third kind of use case, imagine you have an Azure function that requires a human to make a decision. So that human will receive an email. And when that email is received, there will be two buttons on that email that the recipient can click on. The recipient can click on approve or deny, such as a budget request. Okay, so in those events, understand that from the moment the email is sent or SMS is sent, it is now up on the based on the recipient's discretion whether or not to respond. So a user may decide to not respond at all. Okay, or user can respond right away. Now, whatever that duration is, 30 seconds, 3 minutes, 3 hours, our Azure function should not be continuously running, waiting for an event to occur. Okay, so after this fan out demonstration, I'm going to move on to user interaction, human interaction. All right, so it looks like after that 30 seconds, my fan out is done. I'm going to check the location now myself. And notice this is the 4 tasks downloading from Google, Amazon, and MSN. And this is my actual runtime status for my timer sample. Okay, so the fact that it took that long, 30 seconds, is because I have one of those functions that goes to sleep for a while. All right, so that's the function chaining and fan out. Now, in the human interaction, the sample I will show you came directly from Azure Durable Functions. So I will be using an SMS service. Okay, so the durable function will use Twilio to send a randomly generated 4-digit code. Now it is up to me to submit an event through the HTTP event URL to say, hey, I received this code. And then the server, the Azure function will receive this event and wake up and say, okay, you got a 4-digit code. Does it match the one I send you through Twilio? Okay, and the orchestration continues and the function is done. So the await external event needs to somehow suspend the Azure Durable Function. It will be suspended awaiting for user to post back. Okay, so that demonstration comes from the Azure Durable Function phone verification sample. Okay, I want to make sure this is not running anymore. Okay. All right, so this is the SMS phone verification durable function. This durable function sends an SMS challenge against the phone number that I'll be posting. Like that. So when this command is sent, it's going to send a text message to my phone. I will receive a send event post URI. Okay, so that means you have to build some kind of web page front end where the users can trigger this post. And it will be a raise event with SMS challenge response. Now I will need to find out what is the code and instance name in a moment, because I can only get that when I make that request. And this post raises an event in order for the durable function to resume. So that's that. So I'm going to boot this up. All right. So what's interesting is once I make the request, it will send that SMS challenge with a randomly generated code. So this will invoke send SMS challenge function. This will receive a phone number and use the Twilio to send that randomly generated 4-digit code. And it will return that code back to the caller. So this activity is pretty quick. Okay, there's no await in here, so this activity run synchronously. All right. This creates a 90 seconds timeout. So if I'm not fast enough, after 90 seconds, this orchestration will be killed. So that means a user must come back in 90 seconds. So this is a timeout task. Understand this task will complete after 90 seconds. We initialize the authorized flag to false. We give user 3 tries to give us the correct code. Now this is the meat. This is the meat of the demonstration. So in line 42, the challenge response task. Now this is waiting for an external event with that event name and something that can be converted to int. So await task.whenAny, that means there are 2 tasks. One that will complete after 90 seconds. One will complete whenever the event occurs. So after 90 seconds, if there's no response, these events are killed. Okay, there will be a winner, in which case the winner is the timeout task. If I respond with a 4-digit code, the winner will be the response task. So if the winner is response task, let's look at the code. If the code that was returned is the same, we're going to set the Boolean authorize equal true, and we'll break out of this loop, and our function is done. If the winner is not the challenge response task, then we call a break. All right, and we return the Boolean so we know whether authorize is true or false. All right, so with that in mind, I got to be quick on this one because I got 90 seconds. All right, so I'm going to send a request. And that request is going to create a status response. Okay, so what comes back is accepted. Okay, and I got a verification code 7992. So what I need to do is copy this. This always makes me really nervous because it's like clock is ticking. I get exactly 90 seconds. So this is the code. This is the URL that I need to post to. And I need to change the event name. Come on, 90 second, 90 second, 90 second. You got to do it fast or it's going to time out. Yeah, don't want it to time out. I don't want it to time out. Okay. All right, so when I make that post, I'm raising an event. Now, the code I received is 7992. It's not 4964, so I'm going to send it. Okay. But this did not terminate. I forgot to get the status back out again. You know what? I'm going to do the right code this time. 7992. Okay. All right. So this also just returns me that accept it's done. I did not generate because I did not generate this check status response. Okay. Now I'm going to take a look at the Cloud Explorer. And I'm using the, oh, you know what, hold up. This one I'm using local emulator. All right. All right. All right. So folks, this is the human interaction. You can try this out for yourself and understand that we use this as the behind the scene mechanism anytime we have a long running process and we would like to sleep and resume without having to pay for the Azure function to continue running. All right. So folks, these are the most common use cases. All right. Now folks, while I'm talking, there is one really powerful function feature of it. It's called entity function. I know I'm running out of the slotted time a little bit. It was made to be 45 minutes. But this is something for you to think about. Okay. What if our objects can persist in Azure Durable Function as table records? Okay. And the entity stores the state somewhere using an Azure storage, which is infinitely partitioned table. Okay. Method invocation will be serialized, will be serial. I shouldn't use the word serial. Okay, will be serial. Okay. Okay, and the object is ignorant of how it's persistent. All right. To give you an idea of what I am trying to get to, I've created an entity class. Couldn't be any simpler. Alone, I think we can all understand what a loan is. It's the most common demonstration when it comes to transactions. So every loan has an initial amount. So let's say you made a loan for 10,000, 100,000. Okay, and once the loan exists, only transaction that's performed will ever alter the balance. So every time you add a transaction, we maintain an internal transaction history. That's a list of loan transactions. Now, transaction is just a very generic class that contains either a debit, either repay or borrow. Okay, so if you borrow some more, you increase your balance. If you repay, you reduce your balance. Every transaction is recorded in that list, and it is durable function that ensure our list is never lost. Anytime we need to get balance, I'm using a very simple implementation where the get balance computes from the initial loan amount. Okay, so notice that loan amount is never directly modified. Okay, that loan amount stays original. I could make it read only, but it's not necessary here. But imagine that loan amount is initialized once. Okay, here we order by the transaction's timestamp, and if it's repay, we reduce the amount owed. When it's borrowing, we increase the amount owed. All right, and then we return the results. If you want to see all the transaction history, we give it to you. We give you the entire list of loan transactions. Now, I want you to think about this for a moment. This is a plain old C# class. Okay, all the methods are clear. And our traditional understanding is that whenever you instantiate this object lives and dies with your C# heap. So if this object lives in the heap and the heap dies, so goes all of your objects. But not in a durable entity context. When we create this as a durable entity, this object lives in the durable function sort of runtime environment. Remember the original diagram where there are hundreds and thousands of machines attaching to the Azure storage. So this context will live in the storage. And whether I start, stop, or I run this in the cloud or here, the entity will always be there. Okay, so this is a loan entity. To work with entity orchestration, I have a few testing programs. Okay, so I have a client function, and the client function here is to test drive the entity functions. All right, so I can call initialize loan, add transaction, get balance. All of these are durable functions. Okay, so to test drive that, I'm going to create a new loan for Joe. And Joe will start out with a loan of $25,000. I'm going to send a request. Okay, so it's now accepted and it's pretty much done. There's nothing I need to check, but I just want to show you what happens here. Okay, so initialize loan, it will start a new orchestration, which I put in the entity orchestration. So in the initialized loan, okay, the account is the name, Joe. Joe is the account holder. The amount is 25,000. I'm going to create an entity proxy pointing to Joe. One of the two things going to happen. Joe either exists, then my loan points to it, or if Joe doesn't exist, it will create a new object. It's an idempotent call. And it will call the initialized loan with the amount. So when that's done, I have a Joe object. I can say, Joe, I would like to add a transaction. And I'm going to withdraw 1,200. Now, folks, I hard-coded for everything to be a repayment. Okay, you can fork out this from GitHub and make those make those change yourself. But right now, it's adding a transaction of 1,200. It's now making a transaction of 600. And then I can say, Joe, give me your balance. All right. So this gives you a getting status query. So I'm going to follow that. And this is going to tell me Joe currently has a balance of 23,000, which is the current balance. Now I've also created let's say I want to list transactions. So Joe, show me your transactions, and all it's going to do is list out all the transactions for Joe. All right, still running. All right, so there are two transactions. These are the timestamp respectively. And 1,200, 600. Now I also created a synchronous call. So this is not a durable function. So this is a normal Azure function that calls into the durable function context to find Joe. So when I send that request, I am not getting a 202, I'm just getting Joe and the balance and a list of every transactions. Okay, so notice here's what that code looks like. So I'm going to stop this function execution, and I want to show you the client function. This one get loan balance, the function itself is not durable. It's just an HTTP trigger. I will use the durable entity client. Here's the magical class entity client to pull back Joe. So I create a new entity ID using the account. So I'm looking for a loan entity with the account ID Joe. If I can't find it, I'm going to return 404. I can't find Joe's account. If there is, I'm going to cast it to a loan. And all I did is I return Joe, balance, get transaction history. That's it. Now I'm keeping all the entities in a Azure storage account called VC serverless, VC Victor Chin. Okay, VC serverless. And this is the instance. I'm going to refresh this table. Do you see Joe? That's the partition key, add row key. So that means it's automatically partitioned. It stays, the only thing you pay for the next 10 years is one record in Azure table storage. It will forever be running. Yeah, I can publish this to anywhere. I can publish this to, I think I already did that this morning. Okay. I can publish to the Azure portal and run this on the Azure. I can still get Joe back because it's the same Azure storage. It's fast because everything is partitioned. Okay, partitioned to each individual account. Okay, it's long running, so regardless whether my Azure function runs in the cloud or on here on my local emulator, I will always get the same loan. So that is where I need to copy that. All right, so this is called the durable entity along with the HTTP API are some of the new things available to the durable function. All right, so folks, I know I took an extra 10 minutes, but the durable function is interesting in the way it can solve the question of, I have a C# object. How do I make it live for a long time without having to always go to my relational database and turn my object into a table record or take my object saved to JSON? There ought to be a reason why C# object becomes JSON. That's because perhaps a browser client needs to see it. Great, so I turn that into JSON. Perhaps I need to transmit it. I'll turn that into JSON. What you'll notice is in my demonstration code, what protocol? There is no protocol. What query language? There's no query language. Everything is based on the key of the account. What serialization format? Why do we need to deal with serialization format if we just need our object to be persisted and brought back? We can let framework handle all that. We don't have to do this ourselves. See, when I initialize the loan, when I'm adding a transaction, getting the balance back, now this requires my understanding of open connections, sending a query, deserialize things back into an object, take an object, look up the properties, save them as records, and get them back. None of that stuff, none of that ceremonial works are needed. Everything's native to C#. Yeah, that's the beauty of it. So if I'm not making this up, I ought to be able to use that. Hopefully I'll get my, oops, didn't get Joe here. I don't know why. Maybe it's not called API. Note to self, should deploy this first before demo it in the real. Okay, so that deployment didn't go as I expect them to for some reason. Perhaps it's not called API. All right, so folks, the code is available on github.com/Victor Chin. Now, in that Victor Chin, you will find my repository where you can see all these codes. There you go. This is the durable function. Okay. So please do check it out, fork it. Definitely take a look at entity because that addresses our pain point because our common language runtime is limited to a single machine. So if we want our common language runtime to last for the next 10 years, we have to use a relational database and we have to make sure that database runs for the next 10 years. That all becomes a really expensive ceremonial work just to make sure our CLR can live a long time. And this would upend that assumption. We can leave our object natively in this durable function framework. Everything I've demonstrated is available here. The tester HTTP that I use to test for things are available here as well. All right, including the fan in, fan out, the fan out, and activity chaining. All right, they're all here. Code speaks the truth. All right, so please get it working. Check it out. All right, so folks, the session, I think I run the full hour. Question and answer times, folks. Throw at me. give it to me if you have any questions, any things like what is that you're talking about. Let me know, dude. It's your time. Hey, Jagdeep. All right. I hope you like it because to me it's like we know that serverless has to be the way. The whole operating system, runtime configuration, registry, etc config file container. All those things are good, but to be truly scalable, right? To be truly scalable, we still have to seriously consider a cloud native serverless solution. And almost everything we try to adapt these days are serverless. Cosmos DB, Azure Storage, Azure Functions, Logic Apps, they are all serverless. So, hey, thanks, Jagdish. I'm glad you had a good time. Abigail, Elizabeth, Varun, Yangadar, if you have any questions, ask away. If there's anything I can help you with. Oh, the Azure Durable Function is awesome because once you start working with Azure Function, you start to see it's great for stateless workload, but not so much for things that needs to be long running. So this is the durable function. Okay. And definitely take a look at the tutorials. So human interaction is what I just demonstrated. So it'll be exactly the same. Okay. And there are samples. All right. And yeah. The HTTP clients is what I demonstrate with the chaining, while the stateful entity is those entity functions. All right, folks, on behalf of Ops Agility, thank you very much for your time. Seriously, if you have any questions,